how to get the empirical formula of a compound. So determining the empirical and the molecular formula of a compound. The first numerical I've taken, I think you can see this, a compound of carbon, hydrogen and oxygen is found to contain 40% carbon, 6.7% of hydrogen, 53.3% of oxygen. Calculate its empirical formula. If its vapor density is 30, calculate the molecular formula. So first we will be calculating the empirical formula, and then we are going to calculate the molecular formula. Now along with this, the atomic weights will also be given to you. Carbon is 12, hydrogen is 1 and oxygen is 16. This is the information that will be provided to you. So they will be giving you the percentage composition, the name of the elements and the atomic weight. From this particular information, you will be calculating the empirical formula. Sometimes only the empirical formula you have to calculate, and then sometimes according to the information provided, if they have given you the molecular weight or the vapor density, then they will give you to calculate the molecular weight also. So in this numerical only we are doing both the things. For this is just for your understanding. Now you need to make this kind of a table. Now in this table, the first column has the element, second column has percentage composition, the third column has atomic weight, then we have the fourth column, it contains the relative number of atoms, and the last column has simplest ratio. Now what we do in the element, we will write the symbols of the elements that are present here. First we have carbon, then we have hydrogen, and then we have oxygen here. The percentage composition is given to you. So carbon, the percentage is 40%. Then hydrogen, they are given the percentage as 6.7%. This is all information that is provided. You are just copying it. And then oxygen is 53.3%. So we got this information. Now the atomic weight also are given to you. Carbon is 12. Hydrogen is 1 and oxygen is 16. So you got this. Now how to calculate the relative number of atoms? This is important and you must remember this. Now this is the percentage divided by the atomic weight. So what you are going to do is, for getting the relative number of atom, you are going to divide the percentage composition by atomic. I am writing it here so that you remember atomic weight. So the percentage composition here was 40, and then atomic weight here is 12. So you divide this. Then let us do this one also. Then 6.7 is the percentage composition and 1 is the atomic weight. This we are going to divide. And the third one is percentage is 53.3 and the number weight is this. So when you divide this come out to be 3.33. 6.7 divided by 1 comes out to be 6.7, and then this you divide, you will be getting again 3.33. Now the next column, simplest ratio. In the simplest ratio, what you have to do is, out of the these three answers that you got, you have to take the lowest answer out of this, that lowest relative number of atom, and you have to divide all the three numbers by this, all the three answer by that smallest number. So 3.33 itself is the smallest number. So in the first case, 3.33 divided by 3.33, this comes out to be 1. Then this also 3.33 divided by 3.33, this also comes out to 1. Then 6.7 divided by 3.33, this comes out to be around 2.01. So 2.01 can be taken as 2 only. This will give you the empirical formula. Now this is carbon is that we got from here 1. So C1. Hydrogen is 2, H2, and oxygen is 1, so O1. So the empirical formula becomes of this particular compound becomes CH2O. This is the empirical formula. Now we come on to calculating the molecular formula. So first you will be calculating with this proper table is to be drawn. You get marks for each of the steps. So it is very important to mention all the steps properly. Now how to calculate the molecular formula. For calculating the molecular formula, first we will be calculating the empirical formula weight. We have, you know how to calculate the molecular weight. Similarly, we are going to calculate the empirical formula weight. Here in this we have one atom of carbon, so C12, one atom. Hydrogen is 1, 2 multiplied by 1 is 2, and oxygen is again 6, it is 16. So you calculate how much you are going to get. What comes out to be 30. Now the information that is given to you, vapor density. Vapor density according to the question is 30. And I told you what is the relationship between the vapor density and the molecular weight. Molecular weight equals to 2 into vapor density. So 2 into 30, it becomes 60. So molecular weight is 60. Now what you have to do is you have to calculate the value. There is a value n. N equals to molecular weight upon empirical formula weight. Now here n equals molecular weight we have already calculated here. Molecular weight was 60 and the empirical formula weight was 30. So the value of n comes out to be 2. Now how to get the molecular weight formula? Molecular formula equals to n multiplied by the empirical formula. Now n here equals to 2 and the empirical formula was CH2O. So your molecular formula becomes C2H4O2. So this is your answer. This is the molecular formula. This one was your empirical formula and this was the method of calculating.